Hello everyone. This is class 12 chapter 2 inverse trigonometric function lecture 2. In this video we will discuss the properties of inverse trigonometric function.
Properties of inverse trigonometric function. Type f inverse composition fx equals to x. As we know that trigonometric functions are not 1 on 2, but if we restrict the domain, then we can make them 1 on 2, and in that case we can use the properties of inverse, like f inverse o fx is x. We are applying this property in all the trigonometric functions, like sine inverse sine theta is theta, but we have restricted its domain to minus pi by 2 to pi by 2, close bracket or square bracket we can say. Cos inverse cos theta is theta, again we are restricting its domain 0 to pi, close bracket. Tan inverse tan theta is theta, this is open bracket minus pi by 2 to pi by 2. Cot inverse cot theta is theta, open bracket 0 to pi. Sec inverse sec theta is theta. Here we have to remember one thing, it is exactly equal to the cos theta's domain, but theta must not be equals to pi by 2. Similarly, cosec inverse cos theta equal to theta, but here also this domain is similar to sine, but theta must not be equals to 0. Now the second type of function, f inverse x equals to x. We know that when function has inverse of each other, like if we do the composition of inverse function with itself, we are getting the same number, like here x, here x, here also x, here also x, means it behaves as a identity function. Sine inverse x equals to x for all x belongs to minus 1 to 1. Now this time we have to see the range. Cos inverse x equals to x belongs to minus 1 to 1, the range is minus 1 to 1. Tan inverse x equals to x belong to r. Cot inverse x equal to x belong to r because their range is real number. Sec inverse x equals to x belong to minus infinity to minus 1 union 1 to infinity. Here numbers between minus 1 to 1 will not come in place of x. Cosec inverse x equals to x, the same kind of value of x, minus infinity to minus 1 union 1 to infinity. Now students, a very special trick for you. We can convert any sine function, any trigonometric function in inverse term to any of the trigonometric term if we know this trick, which I am going to discuss with you now. Listen it carefully. Now let sine inverse x equals to y. This is equation number A. We can say sine y equal to x, and x I can write x upon 1. Now we know sine theta is perpendicular upon hypotenuse. Perpendicular is x here and hypotenuse is 1. So by the use of I have just made a right angle triangle, and using Pythagoras I can find the length of this third one, which is the base. So I can say this as perpendicular, this is base, and this is hypotenuse. Now I can say cos y as base upon hypotenuse. Base is root 1 minus x square and hypotenuse is 1. So I can say cos y equals to root 1 minus x square. Now tan y, by the same property, tan theta equals to perpendicular upon base. So perpendicular is x and base is root 1 minus x square. So from first we can say y as cos inverse root 1 minus x square, and this way we can say y as tan inverse x upon under root 1 minus x square. So this is y, and this is also y. So from a 1 and 2 we can say sin inverse x equals to cos inverse root 1 minus x square equal to tan inverse x upon 1 minus x square. This is very important formula which can be applied to solve so many questions, especially in competitive examination. This is very special trick. Hope you understood this. Thank you. Now we are taking an example to evaluate sine sec inverse 17 upon 15. I have taken this kind of example to use the previous formulas which I have discussed, a special trick and the first formulas. Let sec inverse 17 upon 15 equal to x. So I can say sec x equal to 17 upon 15. Now what I am going to do, I will make a right angle triangle and sec x, this is hypotenuse and this is the base. So in place of base and hypotenuse I can put these values 15 and 17. Now by using Pythagoras I have found the value of perpendicular, that is 8. Root 17 square minus 15 square will give me 64 and 8 will be the square root of that. So perpendicular is 8. So sin x I can say is equals to 8 upon 17 perpendicular upon hypotenuse. So x is sin inverse 8 upon 17. So from this and from this equation number 1 and 2 I can say sec inverse 17 upon 15 is equals to sin inverse 8 upon 17. Now sin sec inverse 17 upon 15 is equals to, I have just replaced the value of sec inverse 17 upon 15 by sin inverse 8 upon 17. Now the value of 8 upon 17 is lying between -1 to 1. So by using the formula discussed in this video I can say I can remove it, then I can say 8 upon 17 is the answer. Properties of inverse trigonometric functions. First of all, we'll study this. Sine inverse 1 upon x equals to cosec inverse x. We already know that sine and cosec is inverse of each other. But when we are talking about inverse trigonometric function, here we have to take inverse in that way. Cos inverse 1 upon x equals to sec inverse x, and tan inverse 1 upon x equals to cot inverse x. Now I will prove for you the first part. Sin inverse 1 upon x equals to cosec inverse x. Let cosec inverse x equals to y. This implies that if I shift cosec other side, cosec y, x will be equals to cosec y. Implies that x is 1 upon sin y. We know this formula. Cosec y is equals to 1 upon sin y in the basic trigonometric formula. Now if we reciprocal both side, if I say it is x upon 1 and this is 1 upon sin y, if I can say this sin y upon 1, it means sin y, and x upon 1, 1 upon x. Now I am shifting this sin y other side, then it will be sin inverse 1 upon x. then y will be equals to sine inverse 1 upon x. From 1 and 2 you can see that both are same, y equal to y. So sine inverse 1 upon x will be equals to cosec inverse x. Y equal to sine inverse 1 upon x, and cosec inverse x is also equals to y. Because both are equal to y, so from 1 and 2 we can say sine inverse 1 upon x equal to cosec inverse x. Now other properties of inverse trigonometric function is sine inverse minus x equals to minus sine inverse x. Tan inverse minus x equals to minus tan inverse x, and cosec inverse minus x is equals to minus cosec inverse x. I'm just proving the first formula for you. Similarly, you can prove other two formula. Sine inverse minus x equals to minus sine inverse x. So for that what we have to do, let sine inverse minus x equals to y, and I can shift this sine inverse other side. It will be sine y equals to minus x. Now this x will be equals to minus sine y. If I shift this minus other side, then x will be equals to sine minus y, because we know the formula sine minus theta is equals to minus sine theta. This will be in the fourth quadrant, and in fourth quadrant sine is negative. Sine inverse x is equals to minus y, because I have shifted this sign other side, so it will be sine inverse minus x equals to minus y. If I transfer this minus sign other side, then y will be equals to minus sine inverse x. Now you can see this is also y, sine inverse minus x, and here y is equals to minus sine inverse x. It means from 1 and 2 you can say this is equal. Sine inverse minus x is equals to minus sine inverse x. Now third property of inverse trigonometric function, cos inverse minus x is equals to pi minus cos inverse x. Sec inverse minus x equals to pi minus sec inverse x. Cot inverse minus x is equal to pi minus cot inverse x. Just remember, whenever cos, sec and cot will come, pi minus will come. This is a small trick which you must remember. Now we'll prove one of the part. Let cos inverse minus x is equals to y, and now I am shifting this cos in other side, then minus x is equals to cos y, and I'm shifting minus sign other side, then in that case x will be equals to minus cos y. Minus cos y is equals to cos pi minus y, because of this formula cos pi minus theta is equals to minus cos theta. Now x is equals to cos pi minus y. If I shift this cos other side, it will be cos inverse x is equals to pi minus y. Now this implies that y is equals to pi minus cos inverse x. You can check from first and second equation, it is cos inverse minus x, and here also it is y equals to pi minus cos inverse x. So both are equal. So I can say cos inverse minus x is equals to cos inverse minus x equals to pi minus cos inverse x. Now fourth property of inverse trigonometric function, sin inverse x plus cos inverse x equals to pi by 2. Tan inverse x plus cot inverse x equals to pi by 2. Cosec inverse x plus sec inverse x equals to pi by 2. This is very important property. Let sine inverse x equals to y. I'm proving the first one. Similarly, you can prove rest two properties. Sine inverse x equals to y implies that x equals to sine y. Then sine y, I can say cos pi by 2 minus y. We know the formula, cos pi by 2 minus theta is equals to sine theta. Now I am shifting this cos other side. It will become cos inverse x equals to pi by 2 minus y. Now if I shift this minus y other side, it will become plus y equal to cos inverse x equals to pi by 2, and y we already know that it is sine inverse x. So we have proved that sine inverse x plus cos inverse x equals to pi by 2. Now one more very important formula which will be used in the solution of so many questions, and maximum time board is asking question from this: tan inverse x plus tan inverse y equals to tan inverse x plus y upon 1 minus xy. Here multiple of x and y should be less than 1. Tan inverse x minus tan inverse y equals to tan inverse x minus y upon 1 plus xy, and here xy should be multiplied. When we multiply both, answer must be greater than minus 1. Let tan inverse x equal to a. The first part I am saying that it is equal to a, and the second part I am saying it is b. Then x will be equals to tan a. If I transfer this 10 other side, x is tan a and y will be tan b in that case. We know that tan a plus b equal to tan a plus tan b upon 1 minus tan a tan b. In class 11th we have studied this formula. Now tan a is x, tan b is y, so x plus y upon 1 minus xy. Now this 10 we can shift other side, then a plus b will be equal to tan inverse x plus y upon 1 minus xy. Now I am writing tan inverse x in place of a, which we assumed initially, and in place of b tan inverse y. So we have got the first formula. Tan inverse x plus tan inverse y is equals to tan inverse x plus y upon 1 minus xy.
In the next video, we will discuss exercise NCERT 2.2. Thank you for watching.